All right.
All right.
So
Today
we are
we
going
are going
to
at least get
chapter
through
two,
chapter 2
possibly
and possibly
the first
the
section of
first
chapter
section of
7,
chapter 7
because we've got
because
three
we've got
classes.
3 classes to make up for.
You should actually
You should actually be finishing chapter 7 today and taking your test over the weekend,
according to
according to the schedule that we had planned before Snowmageddon 2021 occurred.
But we'll make it.
But we'll make it up.
No worries.
No worries.
If it kills you.
If it kills you, we'll make it up.
So today we're going to talk about
parallel and perpendicular lines, and then we're going to talk about systems of linear equations in 2 variables
and how we
solve those. Hopefully this will be a pretty not too difficult day.
A lot of this
we've already done
at one time or another.
So I'm hoping this will be more of a review day than it will be something totally new for people. So parallel and perpendicular lines. So we got 2 theorems that we use to tell us all about parallel and perpendicular lines. The first one says
that if I've got
2 distinct non-vertical lines in the xy plane, those 2 lines are parallel
if and only if
they have the same slope. For instance, L1 and L2, they have the same slope. They never cross each other. Parallel lines never cross.
The slope of
this line is equal to the slope of this line. We have a notation that we use to denote parallel. It's 2 straight up and down lines between the L1 and the L2. If you see this,
you read it
as L1 is parallel to L2. Okay? But 2 lines are parallel if and only if they have the same slope. That's the definition of parallel lines.
And so what we're going to
do today is first we're going to give 2 equations and ask the question, are they parallel or perpendicular or neither? And then we're going to give you an equation in order to pair and say, give me the equation of the parallel line that passes through this point.
Or the perpendicular
line that passes through this point.
So that part
we've done before. We did that the other day.
You just need a slope and a point
to write an equation.
We did that
Tuesday.
So that'll be something
we've already done this week. The only difference is how we go about getting the slope.
The other day
they either gave it to us or we had to use the slope formula to calculate it. Today they're going to give us an equation and we'll use the definition for parallel and perpendicular to get the slope.
Okay.
But 2 lines are parallel if and only if they have the same slope. So here's what 2 parallel lines look like.
We won't be graphing them. We're done with
graphing until 7-6. So
the second
theorem that gives us the definition of perpendicular lines says that 2 non-vertical lines in the xy plane are perpendicular if and only if the product of their slopes is equal to -1.
So in
plain English, what that means is that they have negative reciprocal slopes.
Because when
you multiply reciprocals times each other, the answer is always 1. 2/3 times 3/2, that's 1.
But they have negative
or inverse reciprocals. So one of them's negative and the other one's positive.
And so the product of
2 slopes that are negative reciprocals of each other is always -1.
But like I said,
in plain English, 2 non-vertical lines in the xy plane are perpendicular if and only if their slopes are negative reciprocals of each other. So that's the whole reason why on Tuesday we spent so much time talking about slope. This is an application of using slope. Perpendicular lines, they cross.
And when they
cross, they form a 90-degree angle.
That's what this little
That's
box
what this little
here-
box here
Yeah.
represents.
90 degree
A 90
right
degree
angle.
or a right angle.
And so the slope.
And so the slope of the L1 here is the negative 1 over the slope of L2. That's how we write reciprocals.
1 over whatever.
1 over whatever.
Here's the notation.
Here's the notation for perpendicular. It's an
upside
upside down capital T.
So
So if you see this,
it's read
it's
as
read
L1
as
is
L1 is perpendicular to L2. Okay?
the upside down.
So the upside down capital T, that stands for perpendicular.
Two straight up
The
and
two
down.
straight up and down vertical lines, that stands for parallel.
Okay.
Okay?
And so again.
And so again, what we're gonna do today is we're gonna first
look at
pairs of equations and decide whether those two equations
are parallel
are
lines,
parallel lines, perpendicular lines, or neither.
They're neither.
They're neither if they cross, but they don't cross at right angles.
So they don't have.
So they don't have
equal slopes
or
negative reciprocal.
negative
slopes.
reciprocal
One
slopes.
of them is
One of them is 1/4 and the other one is 5/2.
Those lines cross.
Those lines
but they don't
cross, but they don't cross
angle.
at a
So
right
they're
angle,
not.
so they're not perpendicular.
So those are our three.
So those are our three
Parallel,
options, parallel, perpendicular, or neither.
And so the first
And
thing
so the first thing we're
today
gonna do today
is to determine
whether two lines are parallel, perpendicular, or neither.
How do we do this?
How do we do this? Well,
They're going to give us.
they're gonna give us two equations.
And so what we're going to
And so what we're gonna do is we're gonna rewrite these equations in slope-intercept form.
Why slope-intercept?
Why slope-intercept form?
Because that's the easiest.
Because that's the easiest way to find the slope,
Right? Y equals.
right? Y equals mx plus b, the slope is the number in front of the x.
If it's already
in slope-intercept form, you don't have to write it in slope-intercept form. Some of them may already be given in slope-intercept form.
But once you have
them both in slope-intercept form, then you just look at the slopes of those two lines.
And one of three
things will happen.
They will either
be equal.
If the slopes are
equal, then the lines are parallel.
If the slopes
are negative reciprocals of each other,
one of them's
2 over 3 and the other one's negative 3 over 2, for example,
then those
lines are perperpendicular.
If the
slopes are not the same or negative reciprocals of each other, then these lines are neither parallel nor perpendicular.
So we're going to look at
examples of this.
The first few
Because the
questions
first few questions on your homework for this section are this.
Are these lines
parallel, perpendicular, or neither?
So here are two lines. Negative 6x minus
2y equals negative 6, and 4x minus 12y equals 2. Are they parallel, perpendicular, or neither? Well, I don't know, because I don't know what the slopes are.
The whole key to this is knowing what
the slopes are.
So I need to take
these equations,
negative 6x
minus 2y equals negative 6, and I need to solve that for y. Because that'll put that equation in slope-intercept form.
So I'm going to add
6x to both sides.
So I get negative
2y equals 6x minus 6, and then I'm going to divide everything by negative 2.
So y equals
negative 3x plus 3.
So
what's the slope of this line?
Negative 3.
Negative 3.
The number,
because remember, y equals mx plus b. That's slope-intercept. M is always the slope.
Now, if
these lines are perpendicular, when I find
the slope of the other line,
that slope's going to be the negative reciprocal of negative 3. So it'll be positive 1/3.
If they're
parallel, it'll be negative 3.
If
it's anything else, they're neither.
So I'm going to
take 4x minus 12y equals 2, and I'm going to subtract 4x from both sides.
So that's gonna give me.
So that's gonna give me negative 12y equals negative 4x plus 2,
And
then divide everything by negative 12.
So y equals.
So y equals negative 4 over negative 12, that's positive
1 over 3.
1 over 3
x,
and then 2 over negative 12, that's negative 1
6.
over 6.
So what's the slope
So
of
what's
this
the
line?
slope of this line?
1/3.
1/3.
So I need
So I need to look at these two numbers right here and ask myself,
are those two numbers
the same?
They're not the same.
They're not the same, so those lines aren't parallel.
Are those two
numbers negative reciprocals of each other?
Yes.
Yes. What's the reciprocal of 3 over 1? It's 1 over 3.
And one of them is
negative and the other one is positive. So they are negative reciprocals of each other.
So
therefore,
these
lines
are perpendicular.
are perpendicular.
On the homework,
you just pick it. It'll be 3 choices: parallel, perpendicular, neither. Pick.
That's how we do it.
But that's how we do it.
So let's do another. Here we've got
y equals 6x minus 3 and 9x minus 2y equals 9. So if I look at the first equation,
y equals 6x
minus 3, that's already in slope-intercept form, isn't it?
So
what is the slope of this?
6.
It's 6.
So I don't
really have to do much for the first one to get the slope.
But the second one,
it's in standard form, so I need to put it in slope-intercept form.
So
9x minus 2y equals 9. So I subtract 9x.
So I get negative
2y equals negative 9x plus 9, and then I divide everything by negative 2.
And so I get y
equals positive 9 halves x minus 9 halves. So what's the slope of the second line? It's
9 over 2.
9 over 2.
So now,
So now,
are those two
numbers the same?
No, they're not.
No, they're not.
Are they negative
reciprocals of each other?
No, they're not.
No, they're not.
They're both
because
positive.
They're both positive. So
eliminates it right there.
there.
But 6 over 1
reciprocal is 1 over 6.
And
9 over 2's reciprocal is 2 over 9.
So they're not
negative reciprocals
They're
of each
not
other.
equal.
They're not equal.
These
These lines
are neither
are neither
parallel
nor
perpendicular. So you would pick neither.
Go to the next one.
And go to the next one. What's that? You want to do one more?
Okay.
Ask and ye shall receive.
Don't ask. Or don't ask and ye shall receive.
Either way,
ye shall receive.
So here's 2x,
so here's 2x plus 5y equals 15, and y equals negative 2/5 x plus 7. So for 2x plus 5y equals 15, to write that in slope-intercept form, I'm going to subtract the 2x from both sides. So that gives me 5y equals negative 2x plus 15.
And then I'm going to
divide everything by positive 5.
So
I get y equals negative 2/5 x plus 3.
So
the slope of that line is what?
Negative
2/5.
My second equation is y equals negative 2/5 x plus 7. Which is already
in slope-intercept form.
So
what is the slope of that line?
It is
negative 2/5.
So
are those two numbers the same? They are.
So what does that mean?
So what does that mean these lines are? Bless you.
Parallel. So that's what we do.
You're always
comparing slopes.
This whole section.
This
is
whole
an
section
application
is
of
an
slope.
application of slope.
So,
Questions?
all
All right.
So the other thing
we
want to
do in this section
is to find
the equation of a line that is parallel to another line
that passes
through a point,
or a line that is perpendicular to another line
that passes through a point.
They'll give you the point. And they will give you an equation
of a line that is parallel or perpendicular to.
And then you have to
find that equation of the parallel or perpendicular line through that point.
Which is good
because we've already done this. We did this Tuesday.
The process
Anyway.
when we learned about
point slope and slope intercept.
Standard form.
You
weren't here.
You can go to Blackboard, and there's a nice long video all about it that you need to watch.
Covers everything. So we're going to use that
same procedure.
We're going to get
the slope and a point, and then we're going to put the equation into point slope form, and then we solve the point slope form for y to get slope intercept.
I'm
not going to make you write these in standard form.
The only forms
I'm going to ask for are point slope and slope intercept.
That's mainly because
one follows from the other.
Use point slope
to get slope intercept.
But it's the
same thing we did in 2.3.
The only difference is how we get the slope. And we get the slope by the definition of parallel and perpendicular. If we want the parallel line,
we use the same slope as the line they gave us.
If we want the perpendicular
line, we use the negative reciprocal of the slope of the line that they gave us.
And then they're going to give
us a point that it passes through.
But when you got the
So
slope
when you got the slope and the point, then you got the equation. So for instance,
if I ask you to
write the equation of the line in point slope form and in slope intercept form,
that passes through
the point -3, 2,
and is parallel
to the line that has the equation y equals 1/2 x plus 2.
So if I'm
parallel
to y
equals 1/2 x plus 2, what's the slope of my parallel line going to be?
1/2.
It's going to be the same as the slope of the original line.
And this original
line is already in slope intercept form.
And then my
point
x1,
y1 is going to be -3, 2.
So I'm going to take
this information right here,
and I'm going to
write my equation.
I'm going to do point
slope first.
So remember point slope form
is y minus y sub 1 equals m times x minus x sub 1.
Where y
sub 1 is the y coordinate and x sub 1 is the x coordinate and m is the slope.
So this is
y minus 2 equals 1/2
times
x minus -3.
And if I simplify
that, I end up with y minus 2 equals 1/2 times x plus 3. That's point slope. Right?
And now how do I
get slope intercept?
Well, if the point
slope form is y minus 2 equals 1/2 times x plus 3, I just need to get the y by itself on the left.
So I'm going to
distribute that 1/2 through those parentheses.
So that's 1/2
times x plus 1/2 times 3.
times x plus 1/2 times 3.
Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3. Plus 1/2 times 3.
And then I need to add
And then I need to add
both
2
sides.
to both sides.
So y minus
So
2
y
plus
minus 2 plus 2 equals 1 half x
plus 3 halves.
plus 3 halves plus 2.
And so y minus
And so
2
y
plus
minus 2
that's
plus
just
2,
y,
that's just y,
equals 1 half
equals
x.
1 half x, and then what's 3 halves plus 2?
How many halves?
How many halves is 2?
4 halves.
4 halves.
So 3 halves.
So
plus
3
4
halves plus
is
4 halves is
7 halves.
7 halves.
And so that
And so that
is the slope intercept.
is the slope intercept form
of the line that
is parallel to y equals 1 half x plus 2
that
passes through the point negative 3, 2.
That's how we do it.
That's how we do it.
Same things
after we get the slope and the point. It's the same stuff we were doing at the end of Tuesday.
Which is good.
Which is good, so that'll reinforce what we did Tuesday.
What's that? You want to do
What's
another
that? You
one?
want to do another one?
Okay.
Okay.
So let's write the
equation of the line in point slope and slope intercept form that passes through the ordered pair 4, negative 7.
And this time it's perpendicular
to the line that has the equation 5x minus 6y equals 5.
So this time
my original line
is
not in slope intercept form.
But I need the slope.
But I need the slope.
So if I solve this equation for
y,
I get
y equals 5 over 6x minus 5 over 6.
So what's the
slope of the original line?
Slope of the
original line
is 5/6.
is 5/6.
So that means
that the slope of my perpendicular line is going to be the negative reciprocal of 5/6. So flip the fraction and change the sign. So it's negative 6/5.
And my x1,
y1 is the point that they gave me for
negative 7.
negative 7.
So it's a lot easier.
So it's a lot easier when they give it to you in slope intercept.
You don't have to do this.
You don't have to do this step.
You just look at it.
You just look at it and figure out what it is.
But if it's in standard
form, you got to put it in slope intercept form first to get the original slope.
And then once you have the
original slope, you've got the other.
So for point
slope,
y minus
y sub 1 equals m times x minus x sub 1.
So y
minus negative 7 equals negative 6 over 5 times x minus 4.
And then
I don't want to leave that as minus negative 7, because that's just what? Plus 7? Right?
So this is y
plus 7
equals
negative 6/5 times x minus 4.
So there
is the point slope form.
And then to get
slope intercept, I'm going to take y plus 7 equals negative 6/5 times x minus 4.
And I'm going to get the
y by itself on the left-hand side. So first I need to distribute the negative 6/5. So negative 6/5 times x is negative 6/5 x.
Negative 6 over 5
times negative 4 over 1
is
positive
24 over 5. And to get y by itself now, I just need to
subtract 7 from both sides.
So y plus 7
minus 7 equals negative 6/5 x
plus
24 over 5 minus 7.
So what is 24
So what is
over
24
5
over 5 minus 7?
How many fifths?
How many fifths
Seven.
is 7?
35 fifths.
35 fifths.
5 fifths is
5 fifths is
7
1, so
times
7 times 5 is 35 fifths.
So 24.
So 24 minus 35
is negative
is
11
negative 11
over 5.
over 5.
And so
that
is my slope.
is my slope intercept form.
And again, we did
this Tuesday.
This isn't new.
This isn't new,
Unless you weren't here.
unless you weren't here.
If you weren't, like I said,
Blackboard is your friend.
why I record.
That's why I record these every day and post them.
What's that? You want
What's
to do
that?
one
You
more?
want to do one more? Okay,
Let's do one more.
let's do one more.
And that leaves us.
Then that leaves us 50 minutes to do the next section.
We're rolling.
We're rolling.
And they get through both.
We may get through both of them today.
So let's write the
equation of the line in point slope form and slope intercept form that passes through the point negative 5, negative 4,
and is
and is parallel
to the line
whose equation is y minus 4 equals 5 fourths times x minus 3. What form is this?
That ain't slope
That ain't slope intercept, and it ain't standard.
Point
It's
slope.
point slope.
So
In this case, the slope is sitting here staring me in the face too.
What's the slope?
What's
of
the
this line?
slope of this line?
5 fourths.
5 fourths.
And since I want
And
the
since I want the parallel line,
of
what's
that
the
one
slope
gonna
of
be?
that one going to be?
5 fourths.
5 fourths.
If I want to go
If I want to go parallel
to y minus
to y minus 4 equals 5 over 4 times x minus 3,
then the
then the parallel slope is going to be the same as the slope of the original line.
And my ordered
pair, x1, y1, is going to be, this time, negative 5,
negative 4.
negative 4.
So again,
this
is what I'm using
to get my equation.
Point slope
Form y minus y1 equals m times x minus x1.
So y minus
negative 4 equals 5 over 4 times x minus negative 5.
And so these
minuses are going to become pluses. So this ends up being
y
plus 4 equals 5 fourths
times
x plus 5.
And again,
there is my point slope form.
And so, if I take
the point slope form
and solve it for y,
I get slope intercept.
So again, I'm going to
distribute the 5 over 4.
So 5 over 4
times x is 5 over 4x.
And 5 over 4
times 5 over 1 is 25 over 4.
And then I'm going
to subtract 4 from both sides.
So I get y
equals 5 over 4x.
25 over
4 minus 4.
How many over 4?
How many over 4 is 4?
16.
16 over 4 equals 4. So
25 over
4 minus 16 over 4
leaves me with 9 over 4.
9 over 4.
And so y
equals 5 fourths x plus 9 over 4. That
is my slope
intercept.
Any questions?
Any questions?
All right.
All right.
Let's move on.
So let's move on.
That's all we're gonna do.
That's all we're going to do in chapter 2.
There's only four sections.
There's only 4 sections in chapter 2, and we did half of them.
The first one was.
The first one was
How to plot points.
how to
which
plot
y'all already
points,
know
which
how to
y'all
do.
already know. how to
Second
do.
one
The
was
second one was
drawing circles.
drawing
which we're not
circles, which we're not going to do. So
We're done with chapter 2.
we're done with chapter 2.
have
Now we just have 3 sections left of chapter 7 for this next test.
So your next test.
So your next test will be 1.9, 2.3, 2.4, 7.1, 7.2, and 7.6.
Next week we will
Next
do
week we will
7.2.
do 7.2 and 7.6.
So your test will be.
So your test will be a
behind.
week behind.
We're already caught up.
We've already caught up 1 or 2 of those days.
So chapter 7.
So chapter 7
about
is all about systems of equations
and
and systems of
inequality.
inequalities.
So what is a
So what
system
is a system of equations? First, we're going to start
with
with 2 variables.
systems of linear
Equations and 2 variables.
What is a system?
What is a system of linear equation and 2 variables? It is the collection of 2 linear equations that we look at the same time.
The solution.
The solution to a system of equations and 2 variables is the set of all ordered pairs that satisfy both equations.
What does it mean?
What does it mean to satisfy an equation?
It means
It means when you plug in the number for the variable, the left-hand side equals the right-hand side.
On Tuesday, we're
On
going
Tuesday, we're going to do systems of 3 equations with 3 variables.
And then next Thursday,
And then next Thursday, we're going to do inequalities.
Replace the equals.
Replace the equals with a greater than or a less than.
That'll be your
And
next.
that'll be your next test.
So a couple of
So
examples,
a couple of examples of systems of equations.
3x minus
3x
2y
minus
equals
2y
negative
equals
9
negative 9 and x plus y
This
equals
is a
2. This is a system of 2 equations with 2 variables.
Negative 3x
Negative
plus
3x
2y
plus
equals
2y equals 11.
8x minus
And 8x
9y.
minus 9y equals negative 2. That's a system. There's 2 equations and 2 variables.
2 equations, 2
2
unknowns.
equations, 2 unknowns.
Now, there's
Now,
four
there's 4
different
different
ways
ways we
we can
can solve these.
I'm going to teach you
I'm
two.
going to teach you 2.
And then on Tuesday,
And then on
when we get to
Tuesday,
the
when we get to the
equations,
bigger
we're gonna
equations, we're going to
do it a different way.
do it a
I'm gonna
different way.
show you how
I'm
to
going
do
to show you how to do it
calculator.
using the calculator
Matrices.
and matrices,
So that you don't have to.
so that you don't have to do elimination 15 times.
But these things
But
can
these
be
things
solved
can be
by
solved
graphing
by graphing them.
These are both linear
These are both
equations.
linear equations. I could graph both of these lines on the same
coordinate
XY
system.
coordinate system,
And then one of two,
and then one of three
things.
things will happen.
Either it'll be two
Either
lines
it'll be
that
2 lines that
at a
cross at a point,
point, or it'll be two lines.
or it'll be
that
2
never
lines
cross,
that never cross,
or it'll be the same
or it'll be
line
the same
twice.
line twice.
And so the
solutions of these graphically are the points where the lines cross,
Point of
the
intersection.
point of intersection.
They either cross at
They
one
either cross at one point, or they cross at infinitely many points.
Or they don't cross
Or they
at all.
don't cross at all.
Okay?
Okay?
But how do I know?
But how do I know whether or not an ordered pair is a solution to a system?
That's the first thing.
That's the first thing you're gonna do on this homework assignment.
Is determine
Is
whether
determine whether negative 1, 3 is a solution to the system.
Well, how do I determine?
Well, how do I determine it? Well, I need to take this ordered pair and plug it into both of those equations for x and y.
And
And if it is a solution, the left-hand side will equal the right-hand side
On both of them.
on both of them.
If it's not a
If it's not a solution, then it won't.
And it only takes.
And it only takes one of them not to work for it not to be a solution.
But for it to be a
solution,
this
this ordered pair has to work for
equations.
both equations.
So what I do
So what I do
is I take
is I take
each one of these
each one of these equations
and I plug in
negative 1 and 3. Negative 1 is x and 3 is y, because it's an ordered pair.
So
does 3 times negative 1 minus 2 times 3 equal negative 9?
I don't know.
I don't know.
What is 3 times
negative 1? That's negative 3, and negative 2 times 3 is negative 6. Does negative 3 minus 6 equal negative 9? Yes.
They have the same sign.
They have the same sign. You add the numbers and keep the sign.
Or you just use your calculator.
Have one. That's why we have one.
So that ordered pair
satisfies the first equation.
Does it satisfy
the second equation?
Is negative
1 plus 3 equal to 2?
It is.
It is.
So it satisfies
both equations. So is negative 1, 3 a solution?
Yes.
Yes.
This is called verifying. We verified
that the ordered pair is a solution to the system.
And you'll do this
on the homework.
At least 2 or 3 times.
2 or 3 times.
What about this? Is 1, 5 a solution
to this system?
Negative 3x
plus 2y equals 11.
8x minus
8x minus 9y equals negative 2. Is that a solution to that system?
Let's find out. For negative
3x plus 2y equals 11, again, 1 is my x and 5 is my y.
So is negative 3
times 1 plus 2 times 5 equal to 11?
Negative 3 plus
10, that's 7, isn't it?
Does 7 equal 11? No.
No.
Do I even have
to check the other equation?
No.
No.
Because if it doesn't work for one of them, it's not going to solve
that system.
So I don't even
have to do the second equation here, because this didn't work out.
I know right now
that 1, 5 is not
a solution. I don't even
have to do the second one.
I could, but
it ain't gonna work either.
8 minus
8 minus 45 is not negative 2. It's
negative 37.
Negative 37.
Now the question is,
how do we get these solutions?
These ordered pairs
that are solutions.
Well,
that's where the methods that we use to solve come into play.
So
there are two different types of systems of equations that you need to be aware of.
There are
the consistent type and there are the inconsistent type. Consistent systems have at least one ordered pair solution.
They may have one,
or they may have infinitely many.
If it has
one solution,
then that is called
an independent system.
If it has
infinitely many solutions,
it is called
dependent.
But both
independent and dependent are consistent systems.
It's just the two
subcategories.
Those are the ones
that have solutions.
An inconsistent
system,
on the other hand,
does not have a solution.
I can't remember
And I can't remember if they ask you if it's consistent or inconsistent, or independent or dependent.
I don't think they do.
I don't think they do.
I think it says
the system has one solution, the system has infinitely many solutions,
or
the system has no solution
when you do the homework.
when you do the homework.
If it has one solution,
If it has one solution, it
it
gives you a box and you type the answer in the box.
If it has infinitely
If it has infinitely many, it gives you a box and you type that in the box.
It has no
If
solution.
it has no solution, then you just pick that one.
So consistent.
So consistent and inconsistent.
Most of the ones.
We're gonna do in here are either gonna have one answer
or no answer.
or no answer.
I don't think you'll
I don't
see
think
one
you'll
at all.
see one at all that has infinitely many.
And the reason for
And the
that
reason for
just the
that
way
is
you
just the way you have to write the answer.
You have to use.
You have to use set builder notation, and it's a mess.
So I didn't put any.
So I didn't put
on
any of
the-
those on the homework.
Most of the ones.
And most of the ones we do
either cross at
either
one
cross
point
at
or
one
they don't
point
cross at
or they
all.
don't cross at all.
So most of the ones.
So most of the ones you're
are
gonna do
have
are either gonna have one solution or they're gonna have no solution.
You shouldn't have.
You shouldn't have to pick the one with infinitely many solutions. So,
We can solve.
these systems by graphing them because they are linear equations.
If I
graph the two
then I get
equations and I get two lines that cross at
point,
one point,
that point
where those two lines cross, that is the solution.
This is what a
consistent, independent system looks like
if you were to
if you were to graph it.
And this point.
And this point right here,
That's the solution.
that's the solution.
Where the two lines
Where the two
cross.
lines cross.
If you graph
If you graph both of the equations and you get the same line twice,
then
then they cross in infinitely many ordered pairs
They're the same
because
line.
they're the same line.
This is what a
Dependent system would look like if you were solving by
I'm
graphing.
not gonna ask you to solve by
you to solve by
graphing.
graphing.
I just want you to
I
see
just
what
want
they
you to
look
see
like.
what they look like.
And if it's an
And if it's an inconsistent system, you're gonna get two parallel lines.
They won't cross.
They won't cross.
Has no solution.
Has no solution.
So
Independent, dependent, inconsistent.
And again,
We're not gonna solve by graphing.
You took intermediate
You took
algebra.
intermediate algebra, you did
in
that
that class.
in that class.
We're gonna use algebra.
We're gonna use algebra to solve them.
And there are two methods.
And there are two methods using algebra that we're going to learn if we don't already know them,
and use to
and
solve
use to solve a system
of
of equations.
The first one's
The
called
first one's called the
substitution method,
substitution method,
which is basically what it sounds like.
What it sounds like.
Substitute
You
into one for the other, and
for
you
the
find
other,
out
and you find out what they are.
And the second
And the
one
second one is called the elimination method,
or the addition
or the
method.
addition method.
Some books call it
Some books
elimination.
call it elimination, some books call it addition.
The reason why.
And the reason why is because when you eliminate one of the variables, you do it by adding the equations together. So
elimination or.
elimination or addition method.
So substitution.
So,
method.
substitution method.
There are four
basic
to
steps to solving a system of
using
equations
substitution.
using substitution. The first step
is to pick one
is
of
to
the two
pick
equations.
one of the two equations. It don't matter which equation you pick, just pick one.
And solve that,
And solve that equation for one of the variables
in
in terms of the other variable. When I do this, I always pick the equation that doesn't have something in front of the x, or it doesn't have something in front of the y. Something that's real easy to solve.
Because I don't want to mess with
Fractions if I can help it.
So I pick one of
So I
the
pick one of the two equations and I solve
the
for
two
one of the two variables.
Doesn't matter which
It doesn't matter
variable
which
you solve
variable
for,
you solve for, it doesn't matter which equation you pick.
Once you do that,
Once you do that, then you take the expression from the equation in step one and you plug it into the other equation for that variable.
So if you have
y equals 2x plus 3, you plug 2x plus 3 into the other equation where there's a y.
And so that gives you
one equation with one variable.
So once you've got one equation with one variable, then you solve that equation for that
variable, and you get x equals 3
or y
equals 2.
And
And since solutions to systems are ordered pairs,
once you get
the value of the first variable,
you have to find the value of the second variable. And you do that
by plugging the number that you got in step 3
back into
the first equation to find the value of the second variable.
You know, the one you
solve for that variable.
And then you'll get
x equals something and y equals something. Your answer is written as an ordered pair.
In parentheses,
x comma y.
And like I said,
the ones we're going to do in here are going to have either one ordered pair solution or none.
But these are the steps. So, shall we do a couple? Or three? Or four? I don't remember how many I put down. So let's solve this system using the substitution method. First equation is x equals 8y minus 9, and the second equation is x plus 8y equals 7. So this is nice because they've already taken the first equation and solved it for x.
I don't have to do anything but substitute it into the second equation.
Because if x equals 8y minus 9,
then x plus 8y equals 7 becomes 8y minus 9
plus
8y equals 7. I substitute that expression into the second equation for x.
And so now
I have an equation that's just in y.
So
8y minus 9 plus 8y equals 7. So 16y minus 9 equals 7. And if I add 9 to both sides, I get 16y equals 16. Then we divide both sides by 16.
And I get y
equals 1.
So I know what y is.
Now, how do I find x? Well, I take this number for y
and I
plug it into the first equation for y. And that will tell me what x is.
So
x is 8 times negative times positive 1 minus 9. So that's just 8 minus 9. So x equals
negative 1. So my solution is the ordered pair negative 1,
1.
If I were to graph
those two lines, this is where they cross.
That's the substitution method. And this one was nice because they already solved one of the equations for a variable. I didn't have to do that step. Here's another one we're going to do by substitution.
X minus y equals negative 5, and then 8x plus 5y equals negative 53.
So
I'm going to take the first equation.
And I'm gonna solve
And I'm
it
gonna
for
solve
X.
it for X.
Why X?
Why X? Because the coefficient of X is already 1.
And to solve
And to solve this for X, I just have to add Y to both sides.
And so now,
in this second equation, 8x plus 5y equals negative 53,
I'm going to
plug in
negative
5y, or negative 5 plus y,
into
that equation where there's an x.
So
this becomes 8 times negative 5 plus y
plus
5y
equals
negative 53.
And so
now I've got an equation that just has y in it.
I can
distribute.
8 times
negative 5 is negative 40. 8 times positive y is 8y.
Plus 5y
equals negative 53. So negative 40 plus 13y
equals negative 53.
And if I add 40 to both sides,
I get
13y equals negative 13.
And then if I divide
both sides by 13,
I get y
equals negative 1.
So if y
equals negative 1, what's x?
X is
negative 5 plus y.
So
x is negative 5 plus
negative 1.
So if I've got two numbers that have the same sign and I'm adding them, I add the numbers and I keep the sign. So this is negative 6.
So x is negative
6 and y is negative 1. So the solution is the ordered pair, negative 6, negative 1.
Most of y'all
have seen this before, pretty sure.
So let's do one more. Because why not? S's and G's. 5x
minus y equals 45, and 6x plus 7y equals 54.
So
I look at these two equations, and the one that I'm going to solve for the variable is the one that has a variable that doesn't have anything in front of it, except maybe a minus.
So I'm going
to take 5x minus y equals 45, and I'm going to solve that for y.
And subtract
5x from both sides, so that gives me minus y equals 45 minus 5x.
And then if I
divide everything by negative 1, I get y equals negative 45 plus 5x.
And so I take
that into the second equation.
And where there's a
y, I'm going to put in negative 45 plus 5x.
So I've got
6x plus 7 times negative 45 plus 5x equals 54.
Or 6x
minus 315 plus 35x equals 54.
I can add my x's together.
I get 41x
minus
315
equals
54.
And then I add 315
to both sides.
So 41x
equals 369.
And if I divide
both sides by 41,
what's x?
What's x?
Well, 4 goes into
36 9 times, and 1 goes into 9 times, so it must be 9.
Again,
this is why you have a calculator.
To do the arithmetic. And so if x
x is 9, what's y?
Well,
y
is
is negative 45 plus 5 times 9, which is positive 45.
And negative 45,
And negative 45 plus 45 is 0.
So x is 9.
So x is 9 and y is 0.
So my solution
is the ordered pair
9, 0.
9, 0. Okay?
Questions?
Any questions
About the substitution.
the substitution method?
It's a lot today.
That's a lot today.
There's still more to come.
There's still more to come.
I got 20 more minutes.
I got 20 more minutes.
22 actually.
22 actually.
Hands getting tired.
Hands getting tired.
Brains turned
turned into mush.
All right.
All right. So let's talk about the elimination method.
So this one has
5 steps.
So you're going to have two.
So you're going to have 2 equations.
And so the first thing
you do is look at them and decide which variable do you want to get rid of.
It doesn't make a difference.
It doesn't make a difference.
The one you like the best.
one you like the
best.
You
want to get rid of X,
get rid of X.
Get rid of Y,
get rid of Y, get rid of Y.
Doesn't matter.
It doesn't matter.
Pick a variable,
Just pick a variable to eliminate.
Now, if that variable
in both of those equations does not have coefficients that add up to be equal to 0,
then you have to
multiply one or both of the equations by some constant
to make them
add up to be 0.
You may only have to multiply one of the equations. Or you may have to multiply both.
Or you may not have to
multiply
either one of them by anything. There may already be a variable that when you add the equations together, they sum up to be 0.
But once you've
multiplied
and made
the coefficients of the chosen variable opposites of each other,
then you add
the two equations together.
And that
eliminates your variable.
Because
negative 5x plus 5x is 0.
So no more X.
So no more X.
And so all you
have left is an equation that has one variable in it.
And then you just solve that equation
for that variable.
You
end up with 2y equals 10.
Divide by 2,
you get y equals 5.
Once you've
figured out what the variable is equal to,
you
then
you
got to find the other variable.
And the
way that we do that is we take whatever that number is for that variable and we plug it back into one of the two original equations.
It doesn't matter
which equation you pick. Just pick one of them and plug that number into it for the variable.
And
then you find the value of the other variable.
So you end up
with an X and a Y.
And so your ordered
pair is your answer.
X comma Y.
X comma Y. Okay.
And you'll see it when
we do it.
It'll make
a little bit more sense when we do a couple of them.
It's hard to picture.
It's hard to picture it just in words.
So when we do a couple
of them, you'll see what I'm saying and what I mean. So
let's solve
the system of equations using the elimination method.
I've got negative
x plus 10y equals 19 and x plus 10y equals 21.
So I want to pick
So
a
I'm gonna
variable,
pick a variable
to
to eliminate.
I look at these
So I
two
look at these
equations.
two equations.
Does either one of
Does
those
either one of those variables,
when I add them up,
when I add them up,
already
already equal 0?
What do I get?
What do I get when I add negative x and positive x?
Isn't that 0?
Isn't that 0?
So that's the variable.
So that's the variable I'm going to eliminate.
I don't have to do
anything to these two equations.
I just take
negative x plus 10y equals 19, and x plus 10y equals 21, and I'm going to add these equations together.
Negative x
plus x is 0.
10y plus
10y plus 10y is 20y.
And 19,
And 19 plus 21
is 40. So
I end up with an equation 20y equals 40.
I
eliminated x by adding.
And then if I divide
both sides by 20, y is equal to 2.
And so if y
equals 2,
how do I figure out
what x is?
Pick one of the two
equations.
I'm going to pick the second one. And if I plug 2 in for y,
I get x plus 10 times 2 equals 21. So x plus 20
equals 21.
And if I subtract 20 from both sides,
I get x
equals 1.
And so x is 1,
and so x is 1 and y is 2. That makes the solution
1, 2.
1, 2. That's how you do elimination.
It's nice
when they already subtract out.
Where the issues
come in is when they don't.
Like for instance,
this system.
6x minus
4y equals 32,
and 5x
plus 7y equals 6.
If I were to add
these equations together right now, does either one of these variables equal 0?
What's 5x?
What's 5x and 6x?
That's 11x.
That's 11x. That ain't 0.
What about
negative 4y plus 7y? That's 3y. That ain't 0 either.
So
I've got to figure out some number or numbers
to multiply
each one of these equations by to make the coefficients of my chosen variable opposites of each other.
So that when I do
add them together, they equal 0.
And the easiest way to do this is to pick the variable that at least has opposite coefficients, opposite signs. Because that way you're multiplying one or both of the equations by positive numbers. Like I wouldn't try
to eliminate x here.
Both of
my x's are positive.
But since
y already has one negative and one positive, that'll be an easier elimination. And so then I just got to figure out what do I multiply them by to get them to be equal to opposite numbers.
And here's what you do. You
take the number in front of the y in the second equation, and you multiply that times the first equation.
And you take the
number in front of the y in the first equation,
and you multiply
that
times the second
equation.
And so when I do
that, I get 42x minus 28y equals 200 and something. 24.
And when I multiply
the second equation by 4, I get 20x plus 28y equals 24.
So
now, look at my y's.
What's negative
28 plus 28?
That's 0.
That's 0, isn't it?
So now I can
add these two equations together.
And so
42x and 20x is 62x
plus 0.
And then 224 plus 24 is 248.
So
62x
equals 248.
If I divide both sides by 62,
I get
x equals 4.
So I know what x
is.
Now I need to figure out
what y is.
So pick an equation. It don't matter which one. I could take
6x minus 4y equals 32.
I'm going to plug
4 in for x.
So 6 times
4 minus 4y
equals 32.
So 24 minus 4y equals 32. If I subtract 24 from both sides, I get minus 4y equals 8.
And then I can divide
by negative 4.
And I get y
equals negative 2.
So x is 4,
y is negative 2.
So my
solution
is the ordered pair
4, negative 2. Okay.
So far,
so good.
You want to do another
You want to do another one? Okay.
So let's solve
4x minus 6y equals negative 6 and 5x minus 7y equals negative 5.
So
this time,
both my
x's are positive and both of my y's are negative. So when I figure out which one I want to get rid of, let's get rid of x this time. Okay?
So I'm going to take
whatever's in front of the x
in the
second equation,
and I'm going to
multiply it times the first equation.
And since
the second equation's x is also positive,
I'm going to take
the opposite
of what's in front of the
x on the first equation. So negative 4
and multiply
that
times the second equation
because they have to be opposites.
They have to
add up to be 0.
I could have multiplied
the top one by negative 5 and the bottom one by positive 4. Same difference.
Or if I wanted to
get rid of the y's, I could multiply the top one by 7 and the bottom one by negative 6.
Or the top one
by negative 7 and the bottom one by positive 6.
It's up to you.
It's up to you.
It's your choice.
It's your choice.
But I decided
to get rid of x.
So this is how I'm doing it. So my
equations become 20x minus 30y equals negative 30.
And
negative 20x plus 28y equals positive 20.
And so now if I look at my x's, when I add those two together,
what happens?
Zero.
It's 0.
If I didn't
make one of those numbers negative, then it wouldn't add up to be 0.
So that's why I had to make
one of these two numbers negative here.
So
20x minus 20x is 0. Negative 30y plus 28y is negative 2y. And then negative 30 plus 20 is negative 10.
Divide
both sides by negative 2.
And you get y
equals positive 5.
And so if we know
y, we just got to find x. So I'm just going to take the first equation
and I'm going to
plug 5 into it for y.
This is going to go
go right here.
So I get.
So I get 4x
minus
minus 6 times 5 equals
negative
negative 6.
Or 4x.
Or 4x minus 30
equals negative
equals
6.
negative 6. And if I add 30 to both sides,
I get 4x.
I get 4x equals 24.
Divide both
Divide both sides by 4.
So you get
and
x
so you get x equals
6.
6.
So x is 6.
So x is 6 and y is 5.
So my solution.
So my solution
is the ordered pair.
is the ordered pair
6, 5.
6, 5.
Any questions?
Any questions?
All
All right.
right. So
You
have two homework
have two homework
assignments
assignments that are
due
due tomorrow night,
We
man.
got through
Because we
both
got
of these
through
sections.
both of these sections.
2.4.
2.4 and 7.1 are both due tomorrow night by midnight.
Neither one of them.
Neither one of them have a whole lot of questions. I think 2.4 has like 7 or 8, maybe 10.
7.1.
And 7.1 has maybe 10,
maybe 11.
maybe 11.
So it's like 20.
So it's like 20 something questions total,
Okay.
okay?